The Northrop Grumman X-47B was a significant step forward in the United States Navy's quest to develop the first carrier-capable unmanned aerial vehicle. Following the promising Pegasus project of the early 2000s, the service collaborated with industry partners to create a truly remarkable piece of engineering: a strike fighter-sized drone. Throughout the 2010s, the X-47 was subjected to several modifications and a series of special tests that not only proved the concept's feasibility, but also demonstrated the machine's dependability. The stakes were high, and it was now up to prove whether such advanced technology could be easily exploited, or if the mighty UAV was too advanced for its time. Until the early 2000s, the U.S. Navy was not fully committed to developing a practical unmanned combat air vehicle, let alone one that could be deployed from a carrier. However, in a concept exploration program led by DARPA, the Sea Service collaborated with the Air Force, Boeing, and Northrop Grumman to develop a single solution for both services. The requirements called for an aircraft capable of deck launch and recovery, integration with command and control systems, and viable operation in the presence of electromagnetic interference from a carrier. Needless to say, the airframe had to withstand saltwater corrosion. The Navy was interested in using the UCAV for reconnaissance missions to penetrate protected enemy airspace and identify targets for future raids. As a result, in early 2001, the service awarded a contract to Northrop Grumman to develop the X-47 Pegasus Unmanned Combat Air System Demonstrator. The resulting demonstrator was a simple black arrowhead with no vertical tailplane. It had a 55-degree leading edge sweep and a 35-degree trailing edge, as well as 6 control surfaces with 2 11s and small flap structures. It also had a single Pratt & Whitney Canada GT15D5C small high bypass turbofan engine. While weapons delivery was not part of the flight test program, the aircraft was outfitted with 2 weapons bays capable of carrying a 500-pound dummy bomb to simulate operational loads. In addition, the Pegasus would test technologies for carrier deck landings. Nonetheless, the collaboration ended in 2006, and each service moved on with its own projects. As a result, the Navy chose Northrop Grumman's proposal for further development. Following the proof-of-concept demonstration, a full-size technology demonstrating UCAV was born, with the exact same size and weight as the projected operational aircraft to conduct more realistic tests. And the X-47B would also have a full weapons bay to carry existing missiles. The Sea Service completed the project as part of the X-47 initiative, which lasted nearly a decade. The Air Vehicle 1 prototype was completed and rolled out in Palmdale, California in late 2008, but additional work was required due to the software's complexity. The aircraft underwent active towed taxiing tests a year later, but did not attempt taxiing under its own power until early in 2010. Formal flights began later than expected, with the first flight taking place at Edwards Air Force Base in early 2011. However, the first flight in cruise mode with the landing gear retracted would not take place until the fall. Meanwhile, the second demonstrator, AV-2, took to the skies at the end of the same year. Although the 2 demonstrators were supposed to undergo a 3-year testing program, their performance was so consistent that preliminary tests were terminated after only 16 flights. Soon after, the Navy resumed sea trials, including carrier launches and recoveries, as well as autonomous in-flight refueling. The models were eventually outfitted with aerial refueling equipment and software in preparation for the following stages. They were never armed, which was notable. The engineers' most significant challenge became overcoming the corrosive effects of the maritime environment on the vehicle's exposed surfaces as the test crew continued refining the remote control techniques required for proper routine functions akin to a piloted aircraft. The company tested a wearable remote control system in early 2012, allowing ground crews to manually steer the drone along the deck. The model then began high-intensity electromagnetic interference testing halfway through the year. When their multiple radars and systems are activated, aircraft carriers may have the most complex electromagnetic spaces of any surface ship. The X-47B began its carrier-based evaluation aboard the U.S. Harry S. Truman in November, and the prototype successfully completed the first at-sea test phase in less than a month. Fortunately, the plane worked with the carrier's flight deck, hangar bays, and communication systems. By the summer of 2013, the X-47B had made an arrested landing on a simulated carrier deck at Patuxent River, Maryland, and a few days later, it had launched from the U.S. George H.W. Bush, marking a watershed moment in drone development as the first time a UAV had been catapulted off an aircraft carrier. Following launch, the UAV was handed over to a second pilot, who successfully flew it from the Chesapeake Bay to Naval Air Station Patuxent River. Later, it demonstrated the ability to perform touch-and-go landings and takeoffs from the deck while in flight. The X-47B also made the first arrested landing of a UAV on a carrier at sea, propelling the program even further toward its goal of developing the first carrier operational drone. However, during the third attempt, the model encountered a technical problem and was diverted to the Wallops Flight Facility in Virginia. When one of the aircraft's 3 navigational subsystems failed, the other 2 detected the issue and notified the operator, who followed the protocols to abort the landing attempt. The mishap proved the drone's dependability and autonomy. At a cost of $813 million, the UCASD program demonstrated the feasibility of operating drones on an aircraft carrier. The fighter-sized drone successfully completed the first-ever autonomous aerial refueling demonstration in the spring of 2015, and the primary test program was completed shortly after. Nonetheless, the Navy decided to convert the previously surveillance and strike-capable aircraft into a reconnaissance and aerial refueling UAV with limited strike capability about a year later. The MQ-25 Stingray carrier-based aerial refueling system, or CBARS, was chosen over the subsequent unmanned carrier-launched airborne surveillance and strike project. Despite its success, the X-47B eventually raised cost concerns and proved insufficiently stealthy for the project's requirements. There was a plan to turn the demonstrators into museum exhibits, but the prototypes remained operational, allowing for further evaluations and variants. The X-47B proved useful as a test bid for the MQ-25 proposal in late 2017, but Northrop Grumman quickly dropped out of the competition. Both UAVs are kept in a hangar and are only used for maintenance. Static engine runs away from the public eye. Nonetheless, the technology and expertise gained from the remarkably successful venture received widespread recognition and awards, including the 57th Annual Laureate Award for Extraordinary Achievements in Aeronautics and Propulsion, hosted by Aviation Week, and the National Aeronautic Association's 2013 Collier Trophy for Excellence in Aeronautic Technology. Please like and subscribe to all of our Dark Documentaries channels for even more technological and military developments. Remember to turn on the notifications bell to be the first to hear about new videos. Keep an eye out.